Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about simple problems that appear simple, but fixing them is probably not so simple.
We always run into those easy problems, right? Or they look easy, right? And then you do the thing and then you regret it in 6 hours.
Yes, yes. And this came to us because I was doing some Redditing, and we'll actually have this as our first example of like what was going on. But I'm like, this is probably what you want to do to fix that. And somebody's like, why would you do that? That's silliness. And it's like, well, but really,
Right,
this is
right. It's
what you
not
want to do.
silliness, it's experience.
Right. Yeah. Experience of understanding it might look easy, but then yeah, like you said, 6 hours later, you're like, oh no.
That thing I thought was fixed isn't really fixed.
Yeah. So Nate, shall we jump into the terminal?
Let's do.
All right. So the specific situation.
Sorry
Uh-oh,
about
did
that.
my window get mangled?
Hold on. There.
The specific situation was somebody's like, hey, this log file is taking up all my disk space. What do I do? Right. And of course, the simple solution would be delete it.
Sure. Big file on your disk. It's a file you don't think you need the content, so just delete the file, right?
Yeah, sounds easy. And so I've gone ahead and set that up here in my lab environment. So, right, df-hp, we can see we're 97% used, right? It's using up a lot of my disk space. When I look at var log, we could see very quickly who is the culprit using 31 gigs of that space as var log messages, right? So the simple solution, just delete that file, and then you get your 31 gigs back.
Right.
But
Totally.
it turns out it's not that simple. So we'll try it. All right. Actually, before we do that, let me go up here. So I'm just running a tail on the var log messages file in my top window there. Oops. And we'll just remove var log messages. Yes. So it's gone, right?
Fixed. We're done. All right. Go get lunch.
Right. I'll look at var log, right? Messages isn't even there anymore, right? Wait a second. What's that stuff happening on the top of my window?
Yeah, sure looks like there's still data going into var log messages. How's your disk space look, though?
Oh, that's a great question, right? Because that was the whole problem that we
That's
wanted
what
to
we
fix.
really care about.
Yeah. Huh. Yeah, it doesn't appear to fix my disk space problem that I noticed.
Get back to work, Scott.
Yeah. So Nate, you know why this isn't working. What's happening here?
So what's happening here is that there's an open file handle, most likely, on this particular file because it's a log file, right? Most times, log files are either being directly written to by a service or a process, or at least the system journal.
Yeah. So to figure this out, we're going to have to install a new tool. So I'm going to do a DNF install of LSOF. LSOF is a command that will list open files, hence its name, LSOF. And so what I can do is I can do an LSOF now that I have the application installed. And these are all the open files on my system, and it gives me things like the process ID and what the file name is, and a bunch of other like data on like what device it's open on and all kinds of other things. But we're interested in var log messages. So I'm going to redo this LSOF, and I'm just going to grep for messages. So, oh, and you guys can't quite see that because it's scrolled off my screen.
Live stream problems.
Yes, live stream problems. How can I show that? Oh. Nope, still not helping me. What I was hoping to do was just like change what it thinks my terminal size was, so it would automatically wrap and on the fly. Not something Scott can fix easily. But what you're looking at here is the processes that have this file open. So rsyslog has the file open, and it gives us our process ID 117959. Also notice that tail has this file open.
Yeah, because you did that on purpose. You were watching the file, right?
Yeah, and what we're missing off of the side here is, actually, let me just put this into a file. And I'll just manually wrap it for you guys.
High-tech stuff right here.
I know.
Problem solving on the fly.
Exactly. Who needs to figure out why their terminals are not correctly sized because of their streaming software? We'll just make manual wraps in our live stream. Live. Okay.
I could change the screen layout, I suppose, but that could end badly too.
Yeah, that's probably not what we want either. This is our first time using this new like ephemeral system, so we're kind of working out the kinks on it.
Right.
All right. So I added in some manual line breaks there so you can see the end of the line. And what you're seeing is that all four of these processes, well, really, one process has it open 3 times and another process has it open 1 time. It has this varlog messages file, which is noted as deleted, still open. And that's why on that top part of the window, we're still seeing data go into it because rsyslog has cached the file handle or file descriptor of this file. So even though we removed the file from the directory tree, because it was still in use, the kernel kept the file descriptor open and the process is still logging to it, which is why it's still getting data. That's also why our df output doesn't show that the disk space has been removed from what this file was using because we actually still have the file on the machine. Right? You can see it's still in use. And so to really delete a file, you need to, 1, remove all occurrences of the file in your directory structure. So things like hard links and other weird things that can sometimes get in the way. You got to remove all those.
Oh, right. We touched on that in a previous episode when we talked specifically about different ways of linking, if I recall.
Yes. And then the second thing you need to do is you need to make sure that no one has that file open. And that's where something like LSOF is really handy. So we would need to restart our syslogd to get it to recache a new file handle for a new file and release its file handle on this. We'd have to terminate the tail command to get it to release the file that it has open so that we could then restart the tail command with a new file that is our new place where we want logs. But this is why you don't want to just delete a file.
Right.
Because when you delete a file, you have to make sure that these conditions are met. All right,
I mean, you could delete the file, but if you notice after you've deleted the file that it didn't go away, this is what you need to check next. You could check this first, especially if the file you're deleting is a log file. There's a really good chance something's writing to that file.
Right, and LSOF will tell you what that process is. But I think this is the larger point is that sometimes files can be used by different programs, and you may have no idea as an administrator what's actually operating with which file. So normally when you delete a file, yeah, it's gone. The disk space is returned back to the system to be used for other things. Like everything's normal. But for things like log files or files that go with specific applications, that may not be the case. And you need to think about that in advance. So, all right. So let me like re-swizzle things to put it back the way it was. And then we'll try this again with a better approach for how we can fix our space problem without needing to restart a bunch of services, maybe take a downtime that we weren't planning on to fix the problem. All right.
Right. Conan Kudo brought up an interesting question. Observant as always, and the question is, why do we still have our syslog? Shouldn't this be getting written by the system journal?
Conan Kudo is familiar with the Fedora ecosystem, and Fedora has kind of moved away from that. But RHEL, we still use rsyslog. We also use journald, but journald's entries get sent to rsyslog as well. Rsyslog has a whole bunch of legacy ecosystem stuff that's still in use by a lot of enterprises, hence Red Hat Enterprise Linux.
Right.
All right.
Compatibility things.
Yeah. All right. So first let me, I lost my process ID. All right. So if we go on to proc 117959 FD. So right here, that's my deleted file that still has open. It's file descriptor 5 for this process. So I'm just going to copy it back into place.
That's helpful.
Okay.
Being able to get it back from the file descriptor there.
Yeah, well, because it's not really deleted until we close these things out. This is also, by the way, how you might be able to save an accidentally deleted file if the file's open. Yeah. If it was open, yes. All right. So let me systemctl restart rsyslog. Okay, and notice now, like, there's no more messages coming into the top of my window because rsyslog has actually cached the new version of the file and is writing to that. So let me go ahead and kill off my tail and reopen it. All right. Oops, tail -f. Okay. So we can do something like logger, right? We can see that it's actually logging and everything's back to the way it was, df-hp, right? We still have too much disk space in use by this file. I can show you var log, right? Yes, indeed, this giant file is back. Okay, so the better approach to dealing with this situation, you've decided you're going to delete the log file, right? So clearly you don't care about its content.
Right.
Okay. What you could do instead is redirect dev null into this file. All right, so if you are not familiar, dev null is a special character device file that makes a never-ending stream of nothing. And we're taking nothing and we're overwriting varlog messages with it. So essentially, we're just going to like blank out all of the content of this file. But because we're directly redirecting into this file, we're not deleting it. We're not changing its inode. We're not changing its file handles. That file is still staying in place exactly as it has been the entire time.
You're just emptying it.
Yeah, I'm just literally blanking that file. But because we're not changing any of this other metadata, rsyslog will still be writing to it. Any other process like tail will still be accessing it. And basically we'll fix our problem of deleting the file, but will not cause the secondary problem of needing to restart services or find processes that may have a file open, right? So let me go ahead and hit enter on this. Bam. Notice that tail produced an error message for us. It said, this file has been truncated, right? And if I look at a listing of varlog messages now, right, was 31 gig before, now 900 bytes, right? And if I look at df, right, we had been using like 90-something% of our disk space, and now we're down to just 10% of our disk space. And you can see from that tail that's running that our syslog is still plopping log files in there and everything's cool. Like the system's all operating normally. And we didn't have to restart anything.
There's been some chat going by about the truncate command. Is that effectively the same thing?
I don't know. I've not used truncate.
I always use the dev null thing like you just did. Is this one of those cases where technology has progressed, but the old hats never learned the new one?
Shrink or extend the file to a different size. So I think this is different. I think it'll like actually work with the open file.
Okay.
So it's keeping the file in place, just like we did with the cat. But it's like allowing you to not just blank the whole file. You could actually like grow or shrink the file as you see fit.
Right.
So you could use truncate to maybe like cleave off some of the file space, but still leave all the file metadata stuff intact.
Right.
That'd be my reading of this this command.
Yeah. Dev null is pretty, I would say, destructive, as all the data that's in there goes away. Maybe with truncate you have more options there. It sounds like at least the commands that are getting thrown into the chat would have effectively done the same thing you just did. Empty out the file, just a different way to get it done. So you could also use something like log rotation to get this done too. That way you might preserve what's in there and then ferry it off to a new system instead of getting rid of it, right? Just a thought.
Well, that was like my more generous Reddit comment was, first, you need to figure out whether this log is too huge because of
right.
It's just grown over a really long period of time. In which case, log rotation is probably your answer for permanently fixing this condition, where more frequently you're rotating the log away to save disk space and compress it and a variety of other things. Alternatively, maybe this isn't a long-term problem that has happened. Instead, something went a little bit haywire over a weekend, and this thing has been logging this tremendous amount of data because something went a little bit amiss.
Right.
And that's a more acute problem. And usually logs are rotated weekly. So that might be something that happens and your log rotation hasn't been triggered yet. But now you're in this place where you have this giant log file you need to handle, and you need to kind of do it quickly because you're running out of disk space.
Right.
And so you can zap it. And when you see that it's coming back and growing at a really big clip, now maybe looking at something like LSOF to determine who's writing to it, to then try and figure out like, what is this process or whatever? Why is it having these problems, and taking it to the next step?
So the takeaway here is the obvious fix, deleting the file, isn't necessarily the right fix. The quick fix is to empty the file, but that doesn't actually fix the problem. I mean, it fixes the immediate problem, but it doesn't really address the cause. Why was the log file so darn big? Maybe that's because there's an issue. Maybe it's because you're logging too much. Maybe somebody turned on debugging and forgot to turn it off, right? It could be, maybe it's not a log file you're talking about. Maybe it's some other kind of file that got written for some strange reason. You want to identify why it's there, why it's abnormally large. Otherwise, it may just happen again next weekend.
Yeah, and I saw that Conan Kudo in the chat said, yeah, sometimes people turn on debug mode, or a developer enables extra logging and forgets to turn it back off again.
Right.
Yeah, that's all 100% usually where this comes from. Or like there's some weird failure, like an NFS something stopped being responsive, or the storage array guys were doing a thing and they accidentally deleted a disk that they didn't mean to delete, and you don't find that out
until... Or a botnet in China is attacking your web application.
Yeah, exactly.
Still a thing you want to analyze, right?
So that's simple problem, right? Need disk space, big log file, simple solution, maybe not.
Not so simple solution.
So Nate, what's your simple problem, not so simple solution?
Sure. So let me get my terminal up here. We're going to go back to our usual Patsy here when it goes to example services. Good old Apache HTTPD, right? So I've got a simple web server set up here. I'm just going to show you and it's getting a forbidden error. Right now, what I'm going to delve into here is just access denied in general, permissions. Right. I come from like a long enough background where I remember when the conventional wisdom on the internet was just open up the file permissions, it'll work, right? And I've seen that enough that I consider that a pretty, like, there's a simple solution, which is to just open up the file permissions. And then there's a more, I guess, thought through solution, right? So we know that on a Linux system that's running SELinux, there could be two major reasons why we're getting an access denied on the web root of a system. So the first thing you'd want to do is identify where is the web root. In this case, I didn't change it. So we're just going to go to var, not etsy, var www. And then we're going to look first at the SELinux contexts on HTML. And -L says to give me like the extended information, the long list. -Z says to include the SELinux contexts. And -D says look at the directory, because at the moment I want to see the directory itself, not the contents of the directory, right? And then we're going to look at HTML. And we see that it's got, experience tells me this is the correct SELinux context. So in this case, at least on the directory, the SELinux context is not the problem. So we're going to look inside of there. And all we really have to do is take away the D, and it'll show us the contents of the HTML directory. And we see that that also has the right context on it. So in this case, it's probably not SELinux that's causing the problem. There's deeper stuff we could look into if we wanted to validate that for absolute certain, but my gut tells me it's not an SELinux problem. But now that we're looking at the file, I see that these permissions here could be the issue, right? What this is telling me, if folks that are viewing are not familiar with what these flags mean in this column, there's essentially columns to this. And the ones that I care about at the moment are that R and W, and then all the dashes after it, right? So read, write are R and W, X would be execute. And what this is telling me is the owner of the file has read and write. Nobody else has anything. Right, so the owner can read and write this file. No other process can access, or I shouldn't say process, no other user can read, write, or execute this index.html file. In some cases, that's fine. It really depends on how your service runs. In this case, I know that Apache does not run as root. Long time ago it did, not anymore. Now it runs as its own dedicated user. This file is owned by root, and the group is root. So this means that the permissions on here are too restrictive. Now, what I could do is just, the easy fix. If I could type, right? And now you can see that the permissions are wide open. And you can see that inside of there, the permissions are also wide open. And if I do my curl command again, look, there's my website. All right, I'm fixed. I can go get my coffee now, right? And like I said, there was a time where you would see this a lot. People, it was famous in the WordPress world. People be like, my WordPress site doesn't work. Oh, just do this. And it's Chmod 777 all down the tree. And those of us that knew better. But that's part of the reason that web hosting, especially WordPress, because there's a lot of people who were building out WordPress sites that didn't quite know what they were doing. They just knew that the platform was really easy to use, getting bad advice from people, and then their site would get compromised. So Scott, why is this a bad idea? Why is it a bad idea to make everything to just Chmod 777 all down the tree?
Well, it is a poor security practice, number one, right? Usually in security practices, you want to give the least amount of access that you can get away with. And here we're actually going the other direction. We're giving the most amount of access by granting all access to every person that may, or process that may interact with this file. So you now allow automated web programs to make changes to files in this directory or execute programs that live in this directory.
So as an example here, I've now exited root. I'm no longer root. I'm now my user. My user, you may have noticed, did not have owner or group access to this file. And yet I should be able to edit this thing, right? So here we'll just go like, you've been hacksawed. And sure enough, I was able to save the file. Now, I'm a local user on the machine, right? So this might not seem like that big of a threat. If you got a local user on the machine that's breaking your website, then you've got other big problems. However, this means that the Apache process itself would be able to do the same thing. In some cases, you want the Apache process to be able to write to certain places inside of your web root. Otherwise, you wouldn't be able to do things like accept file uploads and whatnot. But there's other cases where you absolutely do not. And with this configuration, Apache would be able to change anything it wanted to about that website that's running, including adding in malicious code if someone knew how to make that happen, right? So those are things that you definitely do not want to have happen. So the right way to fix this, of course, is to go more restrictive on the file permissions. There's two formats to chmod. I don't usually use, there's one where you can say like RW and X and who gets RW and X, right? So you can do like O equals RW and, G equals RX, right? Which would be, in my opinion, it's more complicated. It's meant to be easier, but it's more complicated. So I always use the additive numbering, right? That you see us use a lot on this show, which is that 777 that I showed before. So let me get back to root.
And Nate, while you're doing that, just like we did a episode on links, we've done a whole episode on permissions and how to change them and which modes, symbolic or octal mode.
Right.
All that stuff is covered in that file system permissions episode.
So I call this additive. Just a real quick refresher for anyone who's like, what do these numbers mean? R is 4, W is 2, and X is 1. I think I got those straight. So I'm trying to rattle them off. And what you do is, if I want read and write, I add 4 and 2, which equals 6. And that's the number I want. If I want read, write, and execute, then it's 7, because it's 4 plus 2 plus 1, right? So simple mathematics here. So what I'm going to do is I'm going to chmod the directory to 755, which I think is what it was to begin with, although I didn't look, but that's what the CGI bin is. So we're going to go with that. Now, that changes the HTML directory. Now, Scott, why did I make that executable? Because why would I want to execute a directory, right?
Yeah, well, so execute means different things on files versus directories. Right. For a file, it means that it's a program and you can run it like a command. You can type it and it'll run. For a directory, it means access. If you don't have execute, you can't enter or pass through or utilize files that belong in that directory.
Right. So, of course, that fixed the directory, but it didn't fix the index HTML. We're going to do 644 on HTML, which if you are not HTML, index HTML, which if you remember from my addition earlier, that means that it's read, write, or it's read and write for the owner of the file, and it's just read for everybody else, essentially. So the group and everyone else on the system, which is that third column. And now my website should work again. But it's still hacksared because I didn't fix I didn't delete that from the file. But yeah, there you go. So there's always an easy way to fix something and then the right way. All right, Scott, you have the next one, I think. Automatic updates.
I do, but before we got there, there was a little bit of back and forth between me and Shantanu about something you said. You said that Apache doesn't run as root anymore. And Shantanu was like, yes, it does. And so there is a daemon.
The parent process runs as root, doesn't it? Yeah.
That attaches to the privileged ports of port 80 and 443. But it doesn't directly serve content or do other web servery things on the machine. That's what the worker daemons do, and those are all owned by Apache. But what Nate was referring to when he said it's not owned by root anymore was back in the day, all the Apache daemons were running as root, including the worker daemons. So as they were like going around and picking up files or executing a script, they were doing it as the root user account, which meant that anything that your website was doing, it was doing with root authority and capabilities.
Right.
Which was not great.
It was
Now
one of
all
the
that your website does happens as this unprivileged Apache user.
earliest security reckonings that I can recall from my life as a Linux enthusiast. Not even before I was even in it as a career. Was that everyone's like, oh, services shouldn't run as root anymore, and they started fixing that. And so way back before I ever had to deal with it as a true administrator, I remember these conversations. That and SSH versus Telnet. That's how far back this goes.
Yeah, fun, good times. All right, so what I want to talk about is automatic updates. Now, we've talked a few times on the show about automatic updates, and those of you who are regular viewers probably know Nate's and my stance on automatic updates, which is no thank you.
Yeah, at least not for my servers.
Right, mostly because if it automatically happens, I don't entirely know when it is occurring because it's just happening. And sometimes things can cause problems, right? Like a new kernel does something, or a new version of an application changes slightly its behavior, which then affects another application on the machine. And what you end up with is an unexpected outage because an automatic update was applied.
Right.
And that's no fun to be woken up and have to figure that out.
Right. Now, to be clear, updates on RHEL are generally pretty safe, but I would still rather not have things getting updated when I'm asleep that I don't also have means to monitor and automatically fix. Now, this changes in the worlds of like containers, and even with image mode, this is probably a bit better. But in the classic sense of a package mode RHEL system or package mode any Linux system, there's just more risk involved. And I've never been comfortable with automatic updates happening when all of my administrators are sleeping.
Right. And even things like containers, like do you build and deploy new containers while you're sleeping? Because you'd run into kind of the same situation potentially.
So the big difference would be you could do automatic rollbacks. Again, if you're mature enough in your container journey, right, to be able to do automatic rollbacks and health checks.
Well, and that's the thing. You have to build the health checking to determine that you need to do an automatic rollback while your administrators are sleeping without waking them up. But so, automatic updates is one of those things where some people love it. Some people don't like it. There are certain places where I do have automatic updates, like my network infrastructure at home does automatic updates because I want those to apply, and generally they're not problems.
Right.
Until that one day it was a problem and my internet didn't work and everyone in my house let me know about it. And it turned out it was like a weird config thing that they had done in the update, like broke my config. They like overwrite my config. Desktops, right? All my computers I'm looking at right here on my desk, I let those automatic update because I won't care until the next day when I come to work that something is weird or silly and I have to troubleshoot it. And will it be uncomfortable when that happens? Sure, because I'm probably supposed to be on a meeting or something else and I have to figure out why my computer's not working.
Scott, you should get to work 10 minutes early and then that wouldn't happen.
Yeah, I mean, even so, like troubleshooting something within 10 minutes is not always possible. But I have a phone and like other things, other devices that would allow me to continue to do that even though I was troubleshooting my problem, right? So there are certain places absolutely where even I, a automatic update hater, apply automatic updates. But
yeah, I always use the caveat, like a workstation or a desktop, I'm perfectly fine with automatic updates. But on a server, that's when I start to get funny about it. And even there, I've got exceptions, right? If it's something that isn't mission critical, sure, maybe let it do automatic updates. Or something where I've seen the updates occur in the past and they've always been fine. Like I might feel more comfortable there, but there's always that gotcha. So did you have a demo for this? Should I get your terminal up?
I do. So let's say that you're interested in automatic updates. There is a package called dnf-automatic that you need to install to enable automatic updates. So I'm just going to do a dnf list dnf-automatic. And it is already installed on this box, although there's an update. So I'll go ahead and update. How meta that we're updating our automatic updater.
Why didn't it update automatically?
Well, because I don't have automatic updates turned on. All right. So we've got the software, right? dnf-automatic is there. But what is lacking is we haven't enabled it to automatically update the system. And so there are actually a whole bunch of timers run through systemd that we could enable to cause this to be the case. So we could do something like systemctl status dnf automatic timer. All right, so dnf-automatic is enabled, and the dnf-automatic timer will now run periodically and apply updates to the system automatically. But it does so based off a config file. So to actually figure out what it's going to do, we need to look at that configuration file. So that's etc dnf.conf. No, automatic.conf.
There you go. That sounds like it makes sense.
All right. So a little bit difficult to read because of the black on blue or blue on black, but we only really care about the stuff in white anyway, so we'll look at that. All right. So upgrade type, security. There's two types you could set there. Default, which would be any update, and security, which is security specific updates. So even though I turned on dnf-automatic, I'm only automatically updating if one of these is a Red Hat security errata. Okay, so you can actually like be a little bit more fine-grained in what you will want automatically and you don't want automatically. Download updates and apply updates. So when dnf-automatic is triggered, it will download the updates to the system and store them in a cache directory. And then it will apply the ones that it downloaded. So you could do something like come in here and tweak this a bit and say, download updates, yes. Apply updates, no. So you can automatically download everything and have it staged and ready to go on the box, but it won't actually automatically apply them. It'll still require an administrator to do a DNF update to apply them.
Which could save you time, which, that might be a pretty safe way to get that done. At least they're pre-downloaded and cached.
Exactly. And in fact, I think when we talked about doing RPM updates, we suggested to people that they do a DNF download only before they're planning on doing an update so that they could have them cached. And this way you could just have dnf-automatic build that list for you all the time. And then when you actually hit your maintenance window, you apply them out of that cache.
Right.
The reboot. This one is also kind of interesting. So this is a by default configuration. Reboot never. So there are some updates like kernel updates where you can apply them on the disk file system, but you won't actually be using that software until you reboot the machine. Kernel, glibc are two of the ones that are like this. So if you changed reboot to when needed, then if you downloaded a kernel update and applied it, it would then reboot your machine automatically. Or if you downloaded a glibc update and applied it, it would reboot your machine automatically. So this is another piece of like the administrator can decide, yes, I'm interested in automatic updates, but I'm going to stop certain things from happening automatically. So by default, it's never. All right, so
we never want you to install a package and all of a sudden your server spontaneously reboots because you didn't know you had to change the option. By the way, Shantanu is suggesting other Vim color schemes for you because of the blue on black.
Very good. All right, so I think there's other stuff in here that we can look that is in here, but I think these are the core things. But Nate, while I was working on this, I found out something really interesting.
Yeah, what's that?
DNF. So there are actually multiple dnf-automatic timers.
Ah, look at that.
So I installed or enabled this one.
Yep.
So this one uses the config file that I just showed you to determine what its behavior should be when it automatically runs. But notice a couple of the others. This dnf-automatic download timer.
Yeah.
If instead I turn off the one I had and I turn on this one, it will only download into a cache the available updates. So we will only ever download. It doesn't matter what's in the config file. We only ever download because that's what this one does. Only download. The DNF automatically install will always install things. And then the DNF automatic notify only. So further down in that DNF automatic configuration file, there's some contact details that you can put in. So DNF automatic notify only will send an email to whoever's in those contact details saying that there's available updates. But it doesn't do anything else. It just notifies someone of your choosing that there are updates available for this machine. So yeah, like
Handy.
I thought that was kind of cool. You could just change the timer you use and automatically the behavior of DNF automatic changes.
Yeah. Yeah. That sounds really similar to the options that were in that config file though. So I guess you could do it either way.
Yeah.
Or maybe that's what the option in the config file does.
Well, no. So the timer runs DNF automatic with specific options with it.
Okay.
So that it doesn't look at the config file's contents. It only does what it says it's going to do in the timer description.
Okay.
DNF automatic with no extension, right? DNF automatic.timer. It's the one that looks at the config file to figure out what it should do.
All right. So automatic updates, good idea, maybe. Depends on your organization, right? Right. Sounds like an easy fix. It fit the subject for the day.
Oh, we'll just automatically update. Sounds easy.
Sounds easy. All right. So I've got one more that we're going to touch on. Other than the color schemes and some conversations around automatic updates, there weren't really that many questions going by down there. All right. So we're back on my machine here. Get out of my HTML directory here. All right. So making changes that don't persist or reboot, right? And I know this sounds obvious, right? Because, we're going to talk about enabling services and then starting services and forgetting to enable them. That's one. That's the first one I'm gonna touch on, right? So we've got systemctl, of course, is the way you manage services through systemd. We do systemctl. Well, HTTPD is already enabled here, right? So let's turn it off for now. Oop. Okay. So now you're going to see here, I have HTTPD running because it was already running when I ran the disable command. But what's going to happen now is if I reboot the machine, it's not going to bring it back up when I start. It's really common that like I install a new service. I don't know. Let's install MariaDB. I forget if it's MariaDB or MariaDB-server that does this.
-server.
I think it's this one. Is it -server?
Yep. That's the client side.
That's what I thought. Okay, here we go. So we're going to install the MariaDB service, right? Maybe this is a bad example because it requires configuration, but I think it'll start even if I don't set anything up. Let's give it a minute here. Now, if I did a systemctl start on MariaDB, it's going to start it up. But now that it's started, if I were to reboot this machine, or if it were to stop for some other reason, it's not going to start back up again automatically for any, unless I do systemctl start on the database server, the MariaDB, once again. So the way to fix that, of course, is with the enable command. But one that I think every time we use this on the show, somebody in chat says, I didn't know about that option. So let's do, let's take it back down again. And if I did a systemctl start, or sorry, enable, and then add -- now, the flag -- now, and then MariaDB. What it does is, not only does it start up the service, it also tells it to start it at boot time, right? So the enable says, turn it on. That's what these symlinks that it's creating are all about. You can see it's creating symlinks to the multi-user.target and basically the default run level, if you want to call it that, the default target that systemd is booting up the system to. And if you add the -- now, it also starts the service. So the enable says make the symlinks, and -- now says start the service when you're done. So I find that to be really useful. It's a nice little time saver, especially if you're automating this, right? Like say this is a script that you're running that's supposed to install and enable MariaDB. You could have it do the installation and then do an enable -- now, and up it'll come, and it'll enable it. So the next time it boots, it'll be up and running as well. So that's one thing. The next one that always gets me is there are tunables, right, within the Linux kernel that you control with sysctl, right? And there's a nice little config file in etc sysctl.conf, and of course the sysctl.d subdirectory, which is essentially just sysctl.conf at the moment on this machine because I haven't really configured anything. You can make changes in sysctl.conf that'll happen at boot time, but you can also view and change sysctl attributes right from here. We can do systemctl, and if we do -a, it'll show us all of the. That's not what I wanted to do. I think I did something else. There we go. -a. There we go. That's what I wanted to do. I did systemctl instead of sysctl. Why do we name these tools so similarly, Scott? Anyway, sysctl-a will give us all of the configurations, and these are, you know, different tunables and whatnot within our Linux system. Now I can change one right from here. If I just did, let's pick on IP forwarding because it's one that I always have baked into my memory from the days when I was building Linux firewalls. net.ipv4.ip_forward. Okay. Now, if I just do it like this, it's going to tell me what the current value is, and I can just do =1, and this turns on forwarding within the TCP stack of this particular system, right? So now forwarding is turned on. But again, if I reboot this machine, this will go back to whatever the default is. So there's a couple ways to manage this. There's a sysctl-w, which I'm told will write these out, but I couldn't figure it out for the demo today. If I just did a sysctl-w and named it like it's supposed to work, it didn't seem to write anywhere. So I don't know.
It writes to memory.
Is that all it does?
Yes, that's what.
So it won't survive a reboot then?
No.
Okay, never mind then. Don't do that. That's not going to work. So what I always would do is, instead of setting it via sysctl like I just did, let's set it back to 0 for now. Instead of setting it that way, what I would do is put it in the file. Right? Let's go to the end of the file here, and we're going to put in net.ipv4.ip_forward =1, right? Because we want this to come back up at boot time. All right, and then we're going to reload that file essentially with sysctl --system. And what this is going to do is it rereads and it shows it back out here. And then if well, you can see right there that it set it. But now if I go back and reread it, there it is. It's set to 1. So that was the habit I always got in. I would never set them unless I was testing something, right? If I'm just testing a change, I would use sysctl to test the change. If it's a change I knew I had to make, I would change it in the file. And then once I changed it in the file, then I would do that reload of sysctl and bring it back into the actively running system. Now, I see Conan Kudos already in the chat telling me that I should use drop-ins, and that's exactly the next thing I was going to talk about. The other way to do this, of course, is that etsy sysctl.d. You'll notice that actually the sysctl.conf is just a drop-in. It's inside of sysctl.d. You could make a new file in here called like IP forward and .conf and put your new tunable in there. It's really like 6 of one, half dozen of the other. It depends on how you want to manage things. Drop-ins are generally cleaner because then it's easier to say, take one thing out and put another thing in, or maybe you've got a group of tunables that are being used for a specific application, like you have an oracle.conf in here that sets all the tunables for your Oracle deployment, whatever, right? So there's lots of ways to get that done. Just keep in mind that there it is, and you can do it that way. So yeah, sysctl, good stuff. Now, you might wonder why when I set these things, because we're going to talk about another one in a second. In fact, let me get onto that one first. The next one is SELinux booleans. And there was a question earlier about if we're going to touch on firewall D and firewall CMD. I could have done that. It's like, from a concept perspective, it's almost interchangeable here because it's another security feature. And it's something that you can make a change that accidentally borks your system, right? So you could set an SELinux boolean that all of a sudden makes something not work. You could set a firewall rule that, tell me if you've ever done this. You can set a firewall rule or delete a firewall rule that all of a sudden logs you out of the system because now the change you just made takes away the privilege that you had, right? So a lot of these tools are designed to be, let's call them non-persistent or transient when you run the command, so that if you do something like that, you run the command, you hit enter, and all of a sudden your terminal stops responding. Absolute worst case scenario, all you have to do is either get to a console and reload something or reboot the machine. And then it should come back up with the old rule set, right? So SELinux booleans is the next thing I was going to touch on. So we'll give you an example here. So get SEBool -a will tell me all of the SELinux booleans that are available through SELinux on this particular system. You can see there's quite a few in here. One I always like to pick on is there's a boolean that allows HTTPD to connect to a database backend, and that is called HTTPD can network connect DB. So let me just copy and paste that because it's a lot to type. Clear the screen here. So get SEBool, and then you just name the boolean that you care about, HTTPD can network connect DB, and we can see that it's currently off. All I really have to do is say =1, and it'll turn it on, right? Wait, not with get SEBool. I have to set SEBool. Sorry. So set SEBool is the tool that will write a boolean instead of getting it. So if I do set SEBool HTTPD can network connect DB =1, and if I do the get SEBool now, I can see it's on. But again, this is a case where if I were to reboot this system or if I were to reload the booleans, my change is going to go away. And like I said, this is almost like a failsafe. If you make a change and all of a sudden something immediately stops working, all you have to do is reload or reboot and you're back to a working state. So how do you make it persistent? Well, luckily with this one, there's not a file I have to go write. I can just add a dash. I think it's capital P, right? Yeah, -P basically says persistent. Make this a persistent change. And if I do that, it takes another second for it to write because I think it's actually writing out to the policy, the local policy that's on my system. And now if I were to reboot the machine, when it came back up, this particular Boolean would stay on instead of off. So just another gotcha, right? It feels simple. Just, oh, I changed the SELinux Boolean. Oh, I added the firewall rule. Oh, I added the sysctl configuration, and now everything's happy. But 3 months from now, the machine gets rebooted during your patch cycle, and all your configuration goes away, and you're like, why doesn't it work? Then you have to go back and figure out what you changed 3 months ago and do it again, and hopefully make it persistent this time.
That's I think, procedural thing that you also learn over time, right? Like when I was changing system parameters with sysctl, it's change it manually, test,
right,
make the update to make it persistent, reboot,
Right.
verify. Okay, now my maintenance is over and we can move on to the next thing.
Right.
There's always like that thing. Change it in memory, verify it's working, make it permanent, reboot, verify the permanent setting is working.
Right.
Now I can move on.
Because if you don't verify it, it's like, Schrodinger's setting. Is it alive or dead in the box?
Right. Well, Nate, have you ever messed around with Proxys kernel panic?
No. Wait, maybe we have. On this show, we probably have. Will that immediately panic the kernel?
It will immediately panic the kernel.
Perfect. Let's do that.
So if you echo 1 into Proxys kernel panic, it's like, that's it.
Like that?
Yeah, like that.
Oh, there's more than one. There's panic on IO.
Well, that's settings.
These are like settings. I get it.
Yeah, if there's an oops message from the kernel, then it should cause a kernel panic.
Okay. Well, apparently it didn't. It didn't have quite the effect that I hoped it would. It didn't. It didn't like log me out or anything. That would have been
maybe
fun.
we didn't put the right thing in it, but
could be. Maybe you have to echo Scott into it or something.
Could be. But typically, just the machine stops responding. It's done.
That's awesome. I could go look at the console, but I don't know.
But really panic on warning.
Already...
So I don't know why someone would put this in there, but if the kernel issues a warning message, it would just panic the machine.
Good idea. That seems like a great feature. I'm sure somewhere along the way there was a reason for that, and someone's watching this video like, yeah, we do that all the time. It's a perfectly legitimate setting.
Yeah. Well, so I know people that would turn it on because they're like, well, if there's a warning state issued by the kernel, that's something I need to investigate. And I don't want my whatever it is to continue with that being the potential case. And so they would force their machine to blow up. It's kind of like the overcommit memory settings. Like by default, Linux overcommits memory with the kernel, right? Because oftentimes applications request more than they're going to use. So you can tell them, yes, you can have as much as you want. And really, they're not going to use as much as they want. But there are people, they're like, no, we can never have a state where we accidentally give someone too much memory and it causes us to be out of memory and spark up the killer and free memory.
Right.
So instead, we're going to manipulate all those things to make sure that we never overcommit memory to systems because they don't want to get in a situation where killer starts up and does stuff.
Right. Right. Conan Kudo just had an interesting suggestion, or I should say a good suggestion. And I remember this now that he mentions it with sysctl. If you're going to do a drop-in file, right, you can write the file up, don't put it in place yet, and you can use sysctl to read the file with the -p flag. And then if everything works fine, then just copy the file in place. So I used to use that with sysctl.conf. I don't think there was a drop-in system at the time, or if there was, I didn't know about it or it wasn't configured. But I would make the change in etsy sysctl.conf, and I would use -p to read it in instead of the -- system flag. So anyway.
So we had a couple other things on here, but we're already at time. So
yeah, it's already,
this is a good
hour and 2 minutes. Well, of course, we started 2 minutes late, so we're exactly an hour. We're good.
Exactly. So next week we'll have another Into the Terminal. We don't know what it's going to be yet.
It's going to be awesome.
Great idea on Monday. I'm sure it's always awesome.
Yeah. Next Monday, Scott and Nate, we'll figure that out.
Don't forget to mash that like and subscribe button. And we will see you next week, everyone.
Everybody have a great one. Oh, no, I got to get to the things. Here we go. All right. Have a great one.